Contestants, are you ready?
Yes, contestant, I'm the only one, but but the other guy I think it's ready too.
So. Your time begins now.
Perfect. Well, as you may know, in this design, what we have to primarily do is a highly scalable data center design to connect tons of devices, isolated between them, security, and also we want to use this in a public and private cloud. So I will start with the infrastructure that we will need for this, and it will be like in all this data center and spine and lift design, because the closed architecture will allow us to connect all these devices that we need. Actually, I wouldn't do a VXLAN BGP based design with lift and spines, because we actually want another requirements in this design. We want to have an open standard REST API. With these devices, we can do RESTconf and all that stuff. But what also do is isolation, tenant, multi-tenancy, and define a tenant in a programmatic way. And also, we want to do the capability in the infrastructure to do a rollback space. That could be really, really achievable with ACI. So I will start putting an ACI design, spines, and lift. Actually, it has a requirement of a lot of endpoints. Regarding the amount of endpoints that we need, maybe 2 spines is not enough. We are talking about like 5K devices in an environment and 10K for production. So actually, the IP addresses for this endpoint will be reside in the spine table, but they are not giving us any clue if they will be physical, bare metal, containers. They could be whatever of them. So I prefer to start with this simple design. And let's say that this could be scalable. Yes, always achieving with a closed design, lift and spine. For ACI, we will also place AP controllers. This way, controller 1, controller. This way, we have also an even part of controllers for redundancy. We could also have more, but the replic information in ACI is always placed in 3 shards. So more will add resiliency, but will not add more redundancy. So with 3, it's okay, and place it in different lifts to avoid any single point of failure. Yes, we will also have different lifts just for the border outside that we will need to interconnect. Interconnections to internet from the lift. This lift will have only one requirement. We will have more here, but these 2 we will call border lift. And I prefer for these 2 don't have any bare metal server connected, because we are talking about a lot of endpoints, a lot of interconnection between public and private cloud. So if it's private, the connection will be from here. So I prefer these 2 to be dedicated border lift. Yeah, dedicated ones. We will choose specific hardware for them to handle different amount of tables in the layer 3 forwarding tables, yeah? Because we don't want to learn endpoints. We want to use the layer 3 capabilities for these devices. So we will change the configuration of the device. Like when we change the templates on the old switches, but we will do the same on the lift. Yes, this will cover the infrastructure design that we need. We are also having another issue here, that we have multi-tenant, but we want to interact with different clouds. So when we try and we want to start talking about different clouds, like private cloud, public cloud, different hypervisors, because you could use any hypervisor that you want, we have to use another CMP or cloud management platform. I will choose to use an OpenStack deployment because it's open and you have plenty of REST API well documented to use. And also, OpenStack has a native integration with ACI. So here, we will deploy the CMP. The CMP will be OpenStack. And OpenStack will have different roles running. Actually, what I do really want is have a cluster running Nova. Nova is the is inside OpenStack is the project. OpenStack is divided into different projects. Nova is the one who will handle the controllers. It could interact with any hypervisor that you want. We will have actually different cluster for Nova if you want to run KVM, VMware, or Hyper-V. So the endpoint here is that we will run OpenStack integrated between ACI. So when you do a change on OpenStack and when you deploy a tenant or an application inside OpenStack, you will push the policies configuration into ACI. So your endpoint that will reside in the Nova, this Nova cluster, Nova host, will be actually connected to the leaf. Yeah? Different ways. But the important thing is that ACI in this integration will talk with the OBS device that is running, Open vSwitch running here, OBS, and they will exchange information. So your endpoint learning in ACI will be the VMs residing in Nova. So why are we choosing to put OpenStack? Not only because it's open and you have plenty of information and REST APIs to use, because you actually want also to have integration between containers. So I just name it the Nova project, but you have another project running in OpenStack which is called Magnum. Like a Magnum. So why are we using Magnum? Magnum is the project that will handle the containers inside OpenStack. I decided to put Magnum because we will use Kubernetes like an orchestration between our containers, and we will deploy containers in Magnum using different servers that will be hosted in Nova, and also the endpoint information from the containers will be addressed in ACI. So all the information of all the endpoints that we have in the network being there in Nova hypervisor, that could be VMware, Hyper-V, or KVM, or also in Docker containers, like in the Magnum project, will reside in ACI, because ACI has integration with the OpenStack and also has integration against Kubernetes, yes, with the project Contip, or also directly with Kubernetes, as you might see in this Cisco Live, right? So Magnum for containers. And also, we are asked about different stuff here, because actually what we have here is a technical design about which technology shall we place. But we are missing the very important thing stuff. This enterprise want to provide services in private cloud, this design, or also in the public cloud. And also want to offer the end user the ability to choose between all of these clouds. But OpenStack, I don't know if you're aware about, but OpenStack doesn't have an end user UI to be consumed directly. And also, you cannot expect to an end user to enter OpenStack and choose in which Nova cluster or Magnum place it should put the configuration for this application. So we need another CMP level here, and that CMP level, it will be, in this case, Cisco Cloud Center. Why Cloud Center? Because with Cloud Center, we will interact against OpenStack. What we are going to do in Cloud Center, we are going to define all the business rules that the enterprise want to provide to the customers. What is this? The different service that want to provide, like applications, application level, like you want a CMS, you will define it here. And when you do the workflow of create, you will choose in which cloud do you want. You will define the private cloud, this will be your private cloud infrastructure, but you have the requirement to interact against a public cloud. So we can have here AWS, Azure, whatever you want. So with Cloud Center, you could define this high level for the end user to be consumed, like let's say, let's create an application. You want to have the production environment, you have to go to the private cloud because you have the availability that you need. You have the control of your data. You have all the design requirements that you need for production in your private cloud. Or maybe the testing environment or QA or dev could run in a public cloud. And you will use Cloud Center to choose where to place those workloads. And also, in Cloud Center, you could have like an customer to see what is his billings, because Cloud Center will also expose APIs. This is something that I really want to mention, that all the APIs that we are running here, APIs, all are RESTful, because this is one of the requirements that they are asking us. So actually, with this, you have billing, you have customization, skinning, let's go again. Customization, and also you provide the end user experience to consume these services, because if you don't have that, any end user can't create an application in production in depth. So also a requirement, this will be mostly for prod, and this could be for QA. This is just an example. It will be based on the business rule of the people in the enterprise, right? Like the developers. Actually, it's one thing that I don't want to miss is that we are talking about maintain L4 to L6 services between L7 services, between this different approach. This could be done in different ways, but actually one of the most important things to do is to place that in an application-aware way. What does that mean? That if you're running an application here and you want to provide firewall and load balancer ADC capabilities, or maybe IPS, something like that, you could deploy here, but you will face a real good challenge if you want to deploy here. But if you here base that on like physical devices, you couldn't have that here. So you have to start thinking in a way that your application will be deployed with the IPS, firewall rules, and load balance capabilities. And a really good way to achieve that is using in this hypervisor way, because we have an hypervisor here. We can deploy like BNF and do a service chaining between our application and our needs. So our app will have load balancer, virtual, and could be also virtual firewall. Yeah? Could also have that. You will choose on how to interact them. Yes, your app will be different, load balancer and protected with a firewall. But why I am talking about BNF? Because you know BNF you could run here in the Nova, like in KVM, and you will have this BNF. It will be like virtual firewall. Let's say virtual firepower 9 virtual. So you have the ease of the image of that BNF, and you could put in KVM, in VMware, or also you can place it there. You can go to the AWS store and you will have the image for that firewall. So if your application encompasses all this inside itself, so you will deploy your app with a virtual load balancer, let's say a BFI, BBIP, and also a virtual firepower, you could choose which one of them use, and also you can deploy here. So you have the same L4 to L7 application information in the same way, in the private or in the public cloud. So this actually is the most challenging stuff to realize here. And it will depend, of course, that you have to have that information in AWS or in Azure or in the public cloud of choice. Or actually, if you go with a virtual firepower or of that kind of devices, you will have in both places. And the key is that here you're using OpenStack, so you can choose these images and you can deploy. And an important thing that also has to change in the enterprise way that how you deploy is to think the L4 to L7 services attached to the application. So you can move between all of them. Also, you can place it here, you can place it in a container. So actually, another requirement that I wouldn't want to miss is that you want to run containers in public or in private cloud. So I choose Magnum, and I don't say which container orchestration will I use. I will choose to use Kubernetes. Why I want to use Kubernetes? Because in AWS, I could have a virtual instance. Let's say here a virtual server here. And also I will have here my virtual servers. What I will deploy is an agent, which is called the Kube agent, the kubectl, Kube, that will interact here and will be here too. So with a kubectl, a qubit controller, I can choose where this cluster and how this cluster is formed. So to choose where to deploy this application. Maybe I want to deploy an application directly in my private cloud, in my Magnum node. I will do it here. But I want to see the availability of the entire solution. I could just spawn an instance in a container which is running in a public cloud. So, and also this will work with load balancing services, because I want my load balancers to be aware of the location. How will I do that? Just like a global site load balancing solution, just tricking with the IP address, just taking in consideration that this will in my private cloud should have an A record for that, have another A record for my public service, and choose load balance based on whatever you want. Because it's a GSLB, you can choose like latency, like the concept of use a CDN, but in a much easier way, right? So just let me do just a quick review. I don't want to miss any of the requirements that you have, of course.
So I have a question though, real quick.
Go ahead.
How are you going to maintain your security posture from the different clouds, private, public clouds?
Yes, actually that's a pretty one, because you have different policies of security, as you mentioned, but you have to maintain the policy of the security about different instances and applications running in any cloud. So that's why I think that you have to attach to the application the virtual firewall.
Yep.
If you have here a virtual firewall, you have here another virtual firewall.
Yep.
What you will need to have a single pane of view for all of them is like a controller for all of them. Actually, if you deploy virtual firepower, you have the fire. I don't want to lie you with the name, but I remember FMC. I think it's Firepower Management Console. I'm not sure about this F, but it's Management Console for sure. But what gives to you, again, being despite of the name, what this gives you is the ability to have all these virtual firewalls, or actually if you have physical, you can load them too. You will have there all the list of the firewall you have, and you will just choose the policy. Let's call this application firewall 1, just app firewall 1. Sorry for the bad letters. And you will have here the same application firewall, but QA/QA. But all of them are the same applications. You want to ensure the same policy. You just take all of them and you push the same policy to both of them. So FMC is a great tool if you are using, of course you have to use virtual firepower in this case, and actually if you have a security firewall, perimeter firewall, let's say for your whole data center, which is not included in this design requirement, but I know that you must have, if you have a firepower device like a 9300, you could actually load here, and you can push the policy from FMC to that firewall.
Oh, that's great, thank you. So real quick, another question I have is design. So you have one data center right there, idea right there, right, with the spine leaf architecture. What if you add a second data center? Could you go ahead and draw with a different color how you would do that?
Yes, for sure. Actually, that's a pretty one. Let's say I will place it here because I have plenty of space here.
Would it be better, I mean, if you want to do on a new whiteboard and then just don't clear this one, but
new whiteboard?
On a new whiteboard, draw the current one and then draw a secondary?
Share live. That's why
awesome.
just...
Thank you.
Here we go. It's all white. I will start talking to you about what I'm about to draw. Would you want to expand a new data center? Actually, yeah. Actually, you have two options. You can stretch your data center, which in my opinion is a huge,
share it again.
Large domain of failure, and I wouldn't do that. And you have another option, which is AI, which is the multi-pod design. Basically, what you will do is just deploy another ACI closing spine and leaf architecture, and you will interconnect these spines between them. You have some requirements regarding, you have some requirements about the interconnection between them, But what you will do essentially is between the spines, you will talk MP, BGP, BPM between of them, and you will use the VXLAN bits that are reserved to maintain the policy between them. So when you have, here we are. Let us know, Sean. So it will be the same scenario in another data center, but the spines on this ACI, spine and leaf architecture, will be connected in something which is called the IPN.
All right. So yeah,
Okay.
thanks for the background. Let's see. You can go ahead and draw it.
I will draw it now.
Thank you.
Let's call this DC1. Let's call this DC2. Actually, what I just mentioned to you is you have two options. You can stretch this using what is called, I will not draw. I will not draw dust because it's not my design. But my design will be like, and this will be IPN, and you will have here a pod 1, and you will have here a pod 2. You have, of course, some requirements here in these IPN devices. The first one is that the edge device here that are placed in your data center, this interconnection from the spine should be 40 gigs. This is the first requirement that you have. And then you have another requirements in the IPN network. You have in the IPN, you need BDR multicast, you need the HCP relay, and you need, of course, Shumbo frames to be allowed. But inside this, you don't need to have 40 gigs. You can have another interconnectivity. Let's say your demarcation point will be here. You will need another pair of devices here to interconnect this at 40 gigs.
Could you please draw the apex when you're done there? Where
Yes,
you would
of
place
course.
the apex?
And thank you for reminding this, because when you have an interpod, of course, I will not leave this here. Remember that I have 3, 4 here. Well, I could definitely do this, but I don't recommend this, because for the IPN design, it's recommended to have 5 of them. But 5 active. And let's call this one, I will draw it in another color. This will be, well, I draw in another color because this will be a standby APIC, right? Why I'm doing this? Just imagine the case, I don't want this to happen to your enterprise, but this data center just crash out, right? So this DC will have only 2 if I don't put this APICs. But 2 in a cluster of 5 is not majority. So you can write any changes and you can do anything in this 2. That's why I'm putting this APIC. It will be powered on, but will be in a standby way. So when this crash out, you came here, you took this APIC standby, you do some manual interventions, and you can put this online again, and it will behave like 3, and you could start just pushing policies or moving stuff called migration and something like that you want to do in your data center, which is alive. So that will be the deployment for dual side ACI deployment.
Outstanding. Can you go ahead and draw how the internet would be connected at both sites?
You mean internet between them?
So is the IPN where the internet's
Yes.
connected? Okay. Are you going to
No. This need to be full mesh.
That's be full mesh. Now, are you going to be advertising your services out that connection to the internet?
Yes, but to advertise to the internet is actually, that's a pretty good one. Remember that I told you that you have...
Exactly, that's why I was asking.
But now you have, I believe that you have another internet connection here. So actually to use this in a very good way, let's say, you have 2 options. If you have the same network between them, what I will just say, you have to use one of them, because you will have a problem with the ingress policy, because you could advertise in both ways, but you will choose one layer 3 out, L3 out for ACI, respective L3 out, like the standby for the endpoints residing here. What I would recommend is your application doesn't have to be stretched in IP way, let's say, on the same subnet. I would say you want an application in data center 2, okay, let's do it and just use another IP address space from the DC2. So you could advertise from DC2, and actually, because you could advertise the DC2 guys info IP space from the DC1 side. Yes, or you can say, okay, but it's BGP. Maybe I could do something at this level and say, let's use this side with better preference, something like that. Yes, that could be awesome. You will reach the internet, but the ingress traffic will just choose one of the sides. So in this case, that's why I recommend to use different IP space in both data centers, so you could have ingress optimization of the traffic, also ingress, right?
All right, thank you. So are you saying that the applications would not be spanned across the two data centers? They would be specifically in one data center at a time?
No, you of course will have different applications spanned at both data centers. What I'm just saying that you have to have the application that resides in one data center with an IP address scheme for this DC.
Okay.
See, I don't encourage to move the applications like migration, let's say, to have a stretched subnet between them.
Yep.
Why you need a stretched subnet? Come on, if you have the ability to deploy a new application, let's use these containers and this stuff to use different IP address scheme, so you can use in a better way your way out to the internet and also the ingress traffic. Yes, you have the choice, of course. You can do it, yes, of course you can, but it's not a recommendation. Actually, if you were spanning the same subnet, you are extending the failure domain between two DCs. This is not good, not for troubleshooting, not for performance options.
Yeah, so I was just going from like an external services reachability perspective and fault tolerance, right?
Yeah.
So if you're offering a SaaS service, let's say, right, and you have that SaaS pod or that SaaS application, maybe it's a 3-tier application. It's got a web server, an app server, and a database server. And let's say it all lives in pod 1. What happens if pod 1 goes down, data center 1 goes down?
Yes, actually, that's a pretty bad design in your application, let's say, because you are running all in a pod 1. Really, you want an HA in the application where, so you have to, in this way, if you can, of course, you have to do that application HA aware. So what I will do in this case is just have this app running here and the same running here, of course, with application intelligence between them to know the HA. And you can use a global side load balancer to determine where to go. That will be a good approach for the design. Of course, if you have a legacy application that is running only in a DC, if this DC crash, you could have like business requirements like disaster recovery. Depending on your RPO and RTO, you will have like, let's say, replication to the other DC, and you could do like just powering down right now here. And if this DC goes down, actually, your IP address scheme, you could start advertising here because it goes down, right? You don't have any issue. I can start just publishing to the internet my IP address space from the other data center. But of course, that will depend on different, if you have like disaster recovery RPO or RTO requirements in how the replication of the information will be placed, because you will have like metro cluster infrastructure, metro synchronization between the storage devices. That is much more complex than just start thinking in the application in the HA way.
Okay, well, thank you.
Can you explain how you are going to implement multi-tenancy and how you're going to protect the production environment from the QA or the dev?
Yes, for sure. Actually, in ACI, multi-tenancy could be achieved in different ways. You have natively tenants on ACI running. So my first recommendation will be to place each of those tenants that are really tenants for your enterprise in a tenant on ACI. That will be the first step. So I will have tenants isolated. I use, yes, this is for both one. Let's think in this way. I will not slice the ACI fabric, come on. But I will place different endpoints belonging to EPGs. EPGs endpoint groups, there are endpoints that behave the same way, let's call this way. And all these EPGs will belong to one tenant. Actually, for the requirements of the design, I will have a production tenant, I will have a test tenant or dev tenant, and a QA. And that will be fine in ACI. Those tenants will be isolated. They could actually have the same IP address information. Inside the ACI fabric, they will be running on different BRF. So actually, every one of those tenants could have different BRFs, of course. So it's like a double side. And those tenants could have the same IP address scheme, and they will be able to talk each other. But the only problem that you will face if you do that is how to interact with the external network, because the L3 out will know about that. But if you have to use the same IP address scheme to reach external devices, you have actually two ways. Just to use in all the external connectivity the same BRF isolation level that you have for your tenants. Actually, you can do, in ACI, you can achieve that in different ways. What we to external devices, like in layer 2A, and in this device, external one, you could run BRF Lite, and for each VLAN, you will place on defined BRF. Or actually, you could run in a new design which is called Golf. Golf will allow you to interact from the ACI to an external device. In this case, it's only Nexus 7K and ACR 9K, and to interact with MP, BGP, VPN, and use community to tag different BRF. But that is a completely different. Inside the ACI fabric, the tenancy is resolved because each of the applications that you will place in QA, dev, or production will be actually isolated. They will belong to different DPGs that are running in different tenants. I don't know if that answers your question.
Yeah. Okay.
So now I'm gonna move on to like OpenStack again. So in the other diagram you had OpenStack, right? So here, where would you put your CMP? Where would you put OpenStack?
Where will you put here my CMP?
Because now we're talking two different physical data centers, trying to figure out where would you actually put your OpenStack.
Actually, OpenStack deployments in HI is pretty tricky. You have, I don't know how familiar are you with OpenStack, but let's say that you have different projects that are in charge of different points of the architecture, like Identity, which is Keystone, you have the Nova controllers, and you have HA in different ways for all of them. But basically, what you could achieve is have different Nova clusters here. I will start, let's use red for the infra. The first one that I want is where I will place my instance. See? So this will be Nova. This will be Nova. This will be a cluster. Let's say cluster in pod 1.
Okay.
This in 2. But this will be in OpenStack for HA. You have a different concept, which is called availability zones. So I will have this cluster running in one availability zone. All this cluster only belongs to pod 1, and I will have the instance of running here in also another availability zone for pod 2. And this will handle differently. So a failure here will just respawn here. A failure complete in this data center, you will have to use another availability zone. This is only for the instances, let's say like the VMs or bare containers if you want. But you have to take in consideration another point in OpenStack, which is actually the most important, which is the controllers and how you place the controllers in this way. For controllers, the HA recommended for OpenStack is using a cluster of Linux, which is it's based on different products, open source all of them, like Core Sync or HA Proxy. So I will have here Nova controller. I will have here another Nova controller. And they need to be each other connected in a cluster. If you want to achieve HA with OpenStack, actually you have two options. The one recommended for production is to have the cluster spawn with the controllers using this kind of HI deployments. You have actually another one which is not still recommended for production, which is just place your controller nodes inside containers, and you could use Kubernetes or another container orchestration service to respawn if something fails. But I will not recommend that now for production, because actually it's
all right, well, thank you. So moving on from that, like, how would you interact with the public clouds then, from this point of view?
Yes, actually for public cloud...
and maintain multi-tenancy.
Yes, pretty good one. For multi-cloud, actually, remember there is another player coming here. It's not only OpenStack. We need Cloud Center. And why Cloud Center? Because Cloud Center will be the one who will interact with your OpenStack instance and with your public cloud. And what you will actually do is create for each different tenant that you will have in your OpenStack, because in OpenStack you will have different projects for the end user or for the test environments that you have, or QA or production, and you will have to interact also with the public cloud. But from Cloud Center, you could talk to both worlds, because it will use at the end Cloud Center. Let's say it will call to OpenStack API, and when I want to deploy a tenant to the public cloud, it will talk, let's say, to AWS, and I will say, I want that tenant spawned there. Okay, it will create an instance, let's say like you have a virtual server or Elastic Cloud server, dedicated to that tenant, okay? So in Amazon, in this case, just to focus on one of them, you have the concept of VPCs. So those VPCs or virtual private contexts will be isolated because it's the offering that they are bringing to you. So you have to match every tenant that you have, in this case, to a VPC in AWS. Okay. So you have the same tenancy in the both worlds.
That's a manual mapping, right?
Yes, actually, it's not a manual mapping, but in Cloud Center, when you create the tenant, you will create a new, it will choose your tenant from your OpenStack to the mapping on your AWS. Right. Yes, but actually, you have to put and say, okay, I want to create a new VPC in Elastic Cloud.
Awesome.
9 minutes remaining, guys.
Yep.
That's good. That's good.
I'm good right now.
Could you please explain how you implement microsegmentation?
Yes. Microsegmentation, actually, I think it's not required for this, but if you want to do what you will have to do, actually you have to have in mind two places, because you will have VMs and you will have bare metal servers. But let's focus on one data center, because on the other one it will be the same. But for microsegmentation, you have to be aware which of those EPCs or endpoints, of those subnet, if you want to call it that way, want to be micro-isolated between each other. In that case, when you have one of that, what you will do is just deploy that EPC like a micro EPC, like a U EPC. This will have an impact, of course, because if the backing is in VLANs to the bare metal, it will have to spawn 2 VLANs for them, because it's the concept of private VLANs in the leaf, right? That will be the difference. But you have to be aware which services or application. In this case, you are mapping your application directly to an EPC, not to an application profile. And you have to make that EPC micro EPC to allow that. Of course, that for you also, you will have, it's recommended that you have a different kind of different requirement for the Leaf devices, because it's well to recognize the EPC to use the IP. So you will have to use the EX series for the Leaf devices, because they could have in one page in the ASIC, they could just saw the header and identify the IP address for the endpoint. Of course, there is another design requirement that the bridge domain should have IP unicast routing enabled for that.
Okay, thank you. So can you please explain how you handle software upgrades in the fabric?
Yes, for sure. Software upgrades actually are something that is pretty important here, because you want to do a software upgrade in the ACI fabric, but you don't want to do all in the same time in production, of course. So ACI has something which is called maintenance groups. And you could say, okay, let's talk about the event nodes. Let's say this is the spine 1, this is 2, 1, 2, 3. You will have different maintenance group. I recommend to do different maintenance group for spines and for leaf. This will be one group. This will be one group. Let's say all the pairs, all the even. This will be another group. This with the pairs. And what you will do is, in ACI, you have the same concept that you have in UCS, like the catalog that you download the images and then you apply to the blade or to the different pieces like BIOS and stuff. You have the same concept in ACI. So the first thing that you will do is you will download your firmware that you're aiming to, and you will say, okay, I want to schedule the maintenance policy. You could do manually, you could schedule it, but I prefer to do manually in a window, just to be sure. And you will tackle different profiles at the same time. Let's say, let's start with the pairs. So you will do lift 2, lift 4, lift 6. 2 considerations to have in mind. Never do all the lift at the same times. If you have border lift, do a maintenance group separate for the border lift. Maybe you have like border lift the 1 and 3 and you put the same in the same maintenance upgrade. But remember, the border lift has the connection to your external device. So you have to separate the maintenance group in the roles that you have. So I will define 3 maintenance groups, one for spines, one for lift, one for border lift, and all of them will have like the even pairs and the odd devices.
Okay, perfect. Do you have anything else?
No, I think I'm good. Actually, I do have one last thing. So we've gone through a lot today.
Well, yeah.
Do you have any kind of last minute concerns with this design that you've written up?
Yes, actually, as you mentioned, there's something that you have to do manually. Actually, with Cloud Center, you still have to talk with the manually to AWS and do that mapping. I'm expecting like some tool, hopefully open source or by Cisco or by another vendor, let's say, that could have this whole in mind at the same time. Actually, if you saw that I moved to the BNF approach because it was the only way to maintain L4 to L7 with the different clouds. But it should be awesome if we could have something like, let's say I have physical devices here, because maybe in production I have like tons of requirements, like 1 million of connections per second, or something like that. And I could not achieve that actually in these days with a virtual device. And I will put a physical one. But I want to abstract that policy from that physical device and push to a device in a public cloud and have the same concepts behind. So actually, I'm not having that. I'm not having that in the community, let's say. But I'm hoping that this will be resolved very, very soon, because it's the way we are going. Actually, virtual devices are actually nowadays more powerful than also using Intel DPDK or other stuff like paravirtualization, single root IOB. They could use the devices. So you will end with powerful virtual devices that will help us for that. Yes, but we have to wait, man.
Awesome. Well, thank you.
Thank you.
Thanks to you.
Gave us what we needed, so.
Yeah, I agree. So does that mean we have a winner?
I think that means we have a winner, right? I mean, I'm thinking if we both agree that he was a little better, again, I want to make sure that we're not saying that it was a landslide or anything like that. I would say that Ariel won, so.
Yeah, so we have a winner.
Also, we have a winner.